Hello everyone, welcome to Nrcm. Today I'm going to explain about operating system of Unit 3 and the topics are synchronization of hardware and semaphores. Synchronization of hardware. So here like many systems will provide the hardware support for critical section code. Like there are many systems they're providing some hardware support. So in this critical section problem, so if the systems are providing this hardware support also, this critical section problem can be resolved easily in single processor environment. So it works only for single processor environment. So and if it is working for and if we could disallow interrupts to occur while a shared variable or resource is being modified, then only this hardware support for critical section is allowed. So in this manner we could be sure that the current sequence of instructions would be allowed to execute in order without any preemption. So but unfortunately this is not the solution. And it is not feasible in multiprocessor environment. This works only for the single processor environment. So disabling the interrupt on multiprocessor environment, it can be time consuming as the message is passed to all the processors. So this message transmission lag delays entry of the threads into critical section, and the system efficiency also will decrease if we use this kind of I mean if we use this kind of for in I mean it decreases the efficiency in multiprocessor environment. So what they are doing because of this as the synchronization hardware solution, this is not the perfect solution. The synchronization hardware is not the correct solution to implement for everyone. So a strict software which is called as a mutex locks. Mutex locks they were introduced, but in this approach in entry section of the code, one lock is acquired over the critical section resource. And so that is in the previous video I've explained one lock is acquired. So if the process enters into the critical section or the entry section, the entry section will be locked. Locked means the value of the intersection will be locked. And then once the process completes its execution, and it will once it comes outside the critical section, then what happens, this lock will be released, and again it will and again next process can come and execute by saying the log 0. If the log is, just I'm giving example, if log is in at the intersection, if log is mentioned as 0, so it is like the critical section is empty, so then the process can acquire the critical section. If the log is 1, so and the process should think like some other process is executing in the critical section. So with the help of this mutex logs, somewhat the critical sections are the critical sections problems are managed. And next, coming to the semaphore. So what is semaphores? Semaphore, it is a process synchronization tool, and also it is an integer variable, and it is an integer variable. This integer variable is initialized to number of the resources which are present in the system. So here the value of the semaphore s is nothing but the semaphores. It can be modified by only two functions. So first one is wait and second one is signal. So what is wait? So or we can say it is a classification. The classical definition of wait is like wait is it decrements the value of its arguments of its arguments of semaphores as soon as it would become non-negative value. If once the semaphore is non-negative value, so the value will be decremented the semaphore. And next, signal. So signal is like it increments the value of its arguments. So semaphore as an individual operation. So the signal, so like the signal, the value of the semaphore will be increased, and at the during the wait, the value of semaphore will be decreased. And coming to the next properties of semaphores, the main property is using semaphores. It is very simple, and it works with many processes. And one can have many different critical sections with the different semaphores as well, and each critical section has unique access semaphores, and it can permit multiple processes into the critical section at once. These are the different properties of the semaphore. So next we'll be seeing what are the different types of semaphores. The different types are, so there are mainly two types. So first one is binary semaphore and second one is counting semaphore. So the binary semaphore, it is a special form of the semaphore which is used for implementing the mutual exclusion. That is, here mutual locks will be implemented. So it is called as, sometimes it is called as mutex also. And binary semaphore is initialized to 1 and only takes the value 0 and 1 during the execution of the program. Means here, so if the binary semaphore is 1, like it is locked, and if it is 0 means if it is, and it is unlocked. We can do like that. Next, coming to this counting semaphore, so these are used to implement some bounded concurrences. And so here, next, before this, thank you, I just wanted to give some limitations also. We have discussed the advantages, now I wanted to give some limitations of this semaphores. So here, priority in inversion, it is a big limitation. So the priority in inversion is a big limitation of semaphore. And one more, with improper use, suppose if you're using the semaphores with improper use, the process may block indefinitely. I mean, such a situation, it is also called as a deadlock, as we have discussed in the previous slides. So if you are using improperly, so then the process may block. Improperly means the process may block and deadlock can occur. And so these are the two disadvantages or limitations of the semaphores. Thank you.